Hi everyone, welcome back. In this section of the lessons, we will focus on upgrades and partnerships and their effects on crypto. First, let's define what protocols are, and we'll talk about various protocol changes and their possible effects on the currency. So protocol is a rule set or guidelines that regulate the transfer of data between two or more electronic devices. Protocols determine how the data must be structured, how it's organized, and how senders and receivers will process it. Now, in a blockchain network, multiple devices or nodes are connected to each other through the internet and access data records stored on the blockchain. Every blockchain has a list of determined rules or protocols that include how transactions are validated, how the network is governed, how participating nodes communicate, and more rule sets. Here's an example of a peer-to-peer network and what various nodes could look like. They could be in the format of computers, phones, data centers. There's a lot of different variations, but the main idea is that you have some sort of computing hardware that is communicating in a decentralized network with many other computers, nodes, spread across the world. And essentially, this is how a blockchain would run and how communication throughout a blockchain network would be facilitated, where you have all these different computers, all these different nodes communicating and sending information and transaction receipts and bouncing it off all each other all at the same time. Here's a quick rundown of blockchain protocols. What is a protocol? It's the rules and guidelines that are used to achieve a particular task. For example, we could take a look at the Bitcoin blockchain protocol. The Bitcoin blockchain protocol is a set of rules and procedures used to manage the Bitcoin blockchain. And then why do these blockchains need protocols? They're used in a decentralized network to ensure that different aspects of the platform work as intended and to promote interconnectivity, right? If everyone is using different standards of how the information is sent and received and how information is bundled, it becomes much harder for anyone to participate in the network, right? Like if you have no idea how blocks are assembled, or if you don't know the block sizes, let's say person A, B, and C are all using different terminology and different ways of processing the data, a new entrant to the system would have a hard time entering and then participating in that network. So protocols, basically they standardize how these networks operate. Here's just another example of different nodes. Here we see 7 nodes all connected to each other running a blockchain together and just sending information back and forth between one another. Now there's many examples of blockchain protocols out there. We'll take a look at a few. The first one we'll talk about is the Bitcoin protocol. So some things to consider is that it's public, it's a permissionless blockchain, it's not a private blockchain. It utilizes cryptographic hash functions, digital signatures, peer-to-peer networks, private and public key encryption, and a proof-of-work consensus algorithm. This is how transactions are added to the blockchain, basically through proof-of-work consensus or crypto mining. Now, all nodes have complete access to the information on the blockchain. Participants can send and receive transactions without needing intermediaries or any third parties. And the native coin is Bitcoin, BTC. So this is a basic format of if you wanted to do a write-up on a specific blockchain or a specific protocol and you wanted to have a basic rundown of all the major details before going into anything in greater depth or detail. Now here's an example of how transactions on the Bitcoin blockchain would be processed. We have inputs, this would be Bitcoin from previous transactions Joe has received. So let's say this person has received this amount in Bitcoin, and then the outputs. So they would be sending this amount of Bitcoin, 0.1 Bitcoin, sending to Alice's address, and the transaction fee would, let's say, be 0.005 Bitcoin. And then from there, that money is sent to Alice, right? That's the input. She's receiving it. And maybe she's sending a certain amount to Bob. So she's sending 0.015 Bitcoin. But then she has 0.0845 Bitcoin unspent. And then the transaction fees would be 0.005. Finally, Alice or Bob would receive this Bitcoin, this 0.015 Bitcoin. And then he, let's say if he wanted to send it to Gopesh, and he sent it to Gopesh, and we could see his unsent currency, what's remaining, the remaining balance on his address, and the sent amount, and also the transaction fees. Now, another protocol we'll take a look at is the Ethereum protocol. We'll take a look at some differences between Ethereum and Bitcoin. This is really where we start to differentiate the different protocols and different blockchains beyond just their name and their use case, but actually how they're encoded and the finer details, at least the beginning of the finer details that separate them. So Ethereum is a public permissionless blockchain, utilizes cryptographic hash functions, digital signatures, peer-to-peer networks, private and public key encryption, and a proof-of-work consensus algorithm, crypto mining. So at this point, still similar to Bitcoin. Now, Ethereum will convert to a proof-of-stake model, POS, with the completion of the ETH 2.0, or what they're now referring to as the consensus layer upgrade. Now, all nodes have complete access to information on the blockchain. Participants can send transactions without needing intermediaries. And the native currency on this particular network, or this protocol, is Ether, $ETH. This is actually what you buy when you purchase it on your exchange. You're purchasing the native currency on the Ethereum platform. Now, one of the features of the Ethereum protocol is the enabling of smart contracts, which are rule sets and conditions that can be encoded into the blockchain to govern transactions. This is something that separates Ethereum from Bitcoin and many other cryptos. It's also considered deflationary, where one of the more recent updates to the Ethereum protocol, the rule set on the blockchain, EIP 1559, actually introduced a burn mechanism that burns base transaction fees. And we'll take a look at how this works out in the next video. But this is one of the key differences between Bitcoin and Ethereum. So Bitcoin has a diminishing supply rate and issuance rate of Bitcoin, future Bitcoin, through the hashing cycle and the hashing protocol, where after every 210,000 blocks, the block reward given to miners is cut in half. Right now, it's about 6.25, and soon that will be cut in half to a little over 3 Bitcoin, and that will be cut in half again to about 1.5 Bitcoin. Ethereum so far does not have any limitations to the issuance of new Ethereum for the time being. But what it has recently implemented is a deflationary protocol, which would burn some, if not all, of the transaction fees every time someone sends or receives Ethereum. Here's an example of Ethereum development and just some images regarding the Ethereum protocol. So basically the development tools, we have smart contract languages and API libraries. This would be implemented in these various client implementations or the implementation protocols, and then this would interact with the Ethereum protocol specification. Now, if you're not a developer or a coder, you don't necessarily have to know how all of this works, but this is just a basic idea of how these different systems and different languages and rule sets interact with one another, and then finally would interact with the Ethereum protocol.